Well, hi everyone. It's a pleasure to be. It's my first virtual conference, and I'm excited to try this out and see how it goes. We'll be talking about machine learning today, and let's jump straight into it. So, machine learning is one of those. Just remove this real quick. There's a little there's a pop-out window. Just a second. Sorry. Minimize this and move it over here. Okay. Cool. So machine learning is one of those words that's been really hyped up recently. You can usually hear it in tandem with AI, deep learning, blockchain, data science. And when something is so hyped up, it's really hard to distinguish signal from noise. And my hope today is that we'll be able to demystify machine learning. And in order to do that, we have to answer a fundamental question of what is machine learning? So machine learning, plainly put, uses math and statistics to learn about data and predict things based on that data. Usually when I'm learning a new piece of technology, I like to know what it is and where can I use it before I kind of dive deeper. So now let's figure out where can we use machine learning and what are the use cases for machine learning. One of the most kind of famous one nowadays that's on the internet is recommendation engine. So if you ever bought a book off Amazon, when you finish your purchase process, there's a paragraph that says you might also like these items, and there's a list of items. So the way that Amazon came up with those items is they used machine learning, and they looked at your browsing history, your purchasing history, and a bunch of other stuff to kind of compose a list that makes sense. And it's usually a pretty decent list of things that you might actually like. This is, for example, this screenshot that I took is after I bought a programming book. There's a bunch of other programming books that pop out that Amazon thinks I should buy. So this is a very popular way nowadays in the web where you see machine learning. Kind of recommendations engines that are also in Netflix and YouTube. If you watch a movie or a video and afterwards you get similar movies or videos, it works on a similar principle. The next really cool use case is OCR, or optical character recognition, which basically means reading text from an image. So if you ever took a picture of your check with your banking app, let's say using Chase, and you took a picture of your check, and then the amount that was on the check got deposited to your bank account, the way that worked is there was some sort of a machine learning algorithm behind the scenes that figured out how to extract text from an image and deposit the amount to your bank account. The next really amazing use case for machine learning is in medical field, specifically cancer prevention. For example, the latest research that I read about this was that they had newborn babies, and they took their DNA and they used that. They used machine learning to predict how likely they're going to have a certain type of cancer. Which, if you just stop for a second and think about that, it's pretty mind blowing that we're finally helping people in significant ways with machine learning. The next really kind of cool use case are self-driving cars. Everybody heard probably about Teslas. In the heart of a self-driving car is a machine learning algorithm. Algorithm helps the car to figure out what is a road, where should I turn, where should I go, is it safe for me to go to another lane, and stuff like that. So that's pretty exciting, and I think we're going to see more and more of self-driving cars in the future. So now we kind of know what it is, where can we use it. The next question that I would like to answer is, when do we use it? Again, this machine learning as a word, it's a buzzword now, and it's been really hyped up. So it's really kind of sometimes hard to know when to use it. I'm sure everybody heard of SQL. It's structured query language, and whenever we need to analyze some sort of historical data, we can always use SQL. So for example, questions like how many customers did we have last week, or how many customers churned last week, or what was our average revenue in the past 6 months? So answers like that, questions like that can be answered with SQL. Anytime you have to do any sort of historical analysis, SQL is a great tool. However, when you have to predict the future, that's when machine learning comes in. So questions like, how many customers are we going to have in the next 6 months? Or what should a price be of what should the price of our product be? Or what should the salary be of our next employee? When you have to kind of peek behind the curtain and see the future, that's where machine learning comes in, and that's where machine learning can help. So, okay, so now we kind of know when to use it, but when I was learning machine learning, there was this big gap that I realized that gap exists really quickly because, and that gap was math. So when I was learning machine learning, I was using all these Python tools, but there was this big gap that I know that there's some sort of heavy math going on behind the scenes. And my hope with this part is that we'll be able to bridge that gap. So if you look at this equation, it's a kind of a fairly straightforward equation. On the right, you have theta 0 plus theta 1 times x1. And on the left, it's the thing we're trying to calculate, which is called h of theta. So now if you look at this equation, it's the same as previous equation, only thetas are replaced. So theta 0 became 3, and theta 1 became 0.2. And now we have a simpler equation, essentially. The only unknown is x1. Once we have x1, we can kind of calculate the h of theta. So what's cool about this equation is that it's a backbone of an algorithm called linear regression. And kind of to illustrate how that works, imagine we're trying to predict someone's salary. So you're a company and you want to figure out, you want to use machine learning to predict someone's salary. Now, in the real world, to predict someone's salary, there's their years of experience, how they do in the interview, and a bunch of other stuff. But in our little use case, we're only going to pretend that years of experience matter. So what a machine learning algorithm would do is it would figure out these thetas. It would figure out theta 0 and theta 1 through some process, which we're going to talk about later. And then instead of years of experience, instead of x1, it would put years of experience. So let's say I have 2 years of experience. The equation will go something like this: 3 plus 0.2 times 2. So instead of x1, it will be 2. And then if I'm predicting for someone else, whatever their years of experience are, x1 will be equal to years of experience, essentially. So that's about it. It's not, a lot of times machine learning feels like magic, but it's really not. It's just math and statistics. It is hard from time to time, but my hope with this part was we're going to do this linear regression algorithm later live. I'm going to code it, and I just want to show you how the equation looks like behind the scenes. This is really all that it is. So that's kind of how math fits into this whole process. As you go kind of into more complicated algorithms, you'll have different sort of equations, but you have more complicated equations and more complicated methodologies. But I wanted to pick a simple one just to kind of show you guys how to where does the math fit in this whole thing. Cool. So we have 2 types of machine learning algorithms. There's something called supervised machine learning algorithms. And those algorithms are the ones where a data scientist or a machine learning engineer or a software engineer helps the algorithm learn by labeling data. What I mean by labeling data is, imagine you have 3 pictures. One is a person, one is a car, and one is a plant. And for each of those pictures, you would create a little label called car, person, plant, and you would feed those pictures into an algorithm, and then an algorithm would figure out what the picture is based on its label. So that's how it knows that a car is a car. On the other hand, you have algorithms that are non-supervised, and they're the complete opposite of supervised machine learning algorithms. So you don't have labeled data, and algorithm has to figure out everything on its own. In this talk, we'll focus on supervised machine learning, and we'll specifically focus on linear regression. So regression is used to predict something called a continuous value. And all a continuous value is, it's a number. So questions like, what is mortality rate going to be? Or how should we price our product? Or how much money are we going to make in the next 6 months? All those questions can be answered with probably with regression. We already kind of saw this equation. And as I said, it's a backbone of linear regression. And I'm going to kind of talk about it a little bit more. On the right, we have h of theta, which is called a dependent variable. That's a thing we're trying to predict. So in our case, it's salary. Then we have theta 0, which is a constant. we have x1, which is called an independent variable or a feature. In our case, that was years of experience, but imagine that could be like a level of education or interview score or something like that. And then we have theta 1, which is called a coefficient. Coefficients are actually really interesting. The way you can think about them is they represent how good of a relationship do you have between x1 and h of theta. So for example, if somebody is driving a red car, their coefficient will be pretty small, because it doesn't really matter what type of car are you driving or what color is your car if you're predicting someone's salary. On the other hand, if you have somebody's years of experience, the coefficient is going to be pretty high, because that's a really important thing as far as the salary goes. So that's what coefficients are. And then we saw this equation in the previous slide, and I told you guys that the linear regression goes through some process to figure out these thetas. And I'm going to try and explain that process now intuitively. I'm not going to go into math, but hopefully intuitively it's going to make sense. So in order to figure that out, let's pretend again we're trying to solve a problem of salary prediction, and let's plot this equation in a graph. So it's a 2D graph. On x1, I can't point, never mind. On x1, we have, that's an x-axis, and it represents our years of experience, and h of theta is our y-axis, and it represents our salary, right? There's a bunch of these red dots. These red dots, you can think of them as real data points from our database. So we hired 50 employees, for example, and we pulled all 50 of them from our database, and we plotted them on a graph based on their years of experience and their salary. And then there's this interesting line, like it's almost 45-degree line that's drawn here, and those are actually thetas, right? So theta 0 would be the y-intercept or intercept on h of theta axis, and then the slope of the line would be, the slope of the line would be 0.2. So if you think about it, it's fairly easy to predict someone's salary based on their experience if you have that line. So if you have 5 years of experience, you would kind of figure out where 5 is on x1 axis. You would draw a line up, and then you would draw a line to the left, and then you could read from y-axis how big someone's salary is. So the question really becomes, how do you find this line? And the way you find this line, there's a few ways to do it, but I'm going to explain one way. And the way the algorithm does it is basically it goes in and it draws a bunch of these lines, and the line and it picks the best line. How do we define the best line, or the best fit? In machine learning, we call it the best fitted line. The way we define the best fitted line here is it's the line where the difference between the actual value and the predicted value is the lowest. So the difference between this red dot and the kind of projection of the value on the best fitted line should be the lowest. And the reason why we want it the lowest is because we want to predict as accurately as we can based on these data points. That's kind of intuitively how it works. I know I'm probably talking super fast, and there's a bunch of information that's coming out of me, so feel free to ask me questions. But hopefully, at least intuitively, it makes sense of how does this thing work. There's a whole math piece behind it, which, again, I didn't want to get into, but I'm more than happy to point to different resources to do so. Before we get into coding, I want to talk about problem solving. So when you get a machine learning problem, there's different pieces to it, right? So you have to gather all the data that you need. And that could probably be from your database, from logs, from a bunch of CSVs, a bunch of different places. You have to then clean the data and make sure it's good. Then you have to pick the algorithm, and then you have to implement the algorithm. And sometimes you have to repeat the process multiple times. The kind of the code that I'm going to show you, I already did the first and second part. We're just implementing the algorithm. But in reality, a lot of machine learning is getting the data and cleaning the data and figuring out what algorithm you need to use. And for example, in big companies, these three boxes are sometimes three different disciplines. If that makes any sense. So data gathering will be data engineering, and then picking the algorithm and implementing the algorithm would be split between data science and machine learning. So in a big company, there are different disciplines. In a smaller company, one person does all of that, but this is kind of roughly the process that you have to go through. Okay, cool. Now let's code some machine learning. Let's do some coding. Basically, the problem I'm trying to solve is predicting someone's salary based on their experience. It's kind of the easiest way to get linear regression, at least in my opinion. I have to exit out of this. I'm going to be using, hopefully, I'm going to be using something called the Jupyter Lab. It's basically Jupyter Notebook IDE. You don't have to worry about any of that. It's just an IDE in the browser that runs Python, right? Cool. So what we're going to do is we're going to create a console here, and this is again, this is a file, a Python file. And this is the console. You can do some math here. It's a Python console, right? So you can do this. Cool. So basically, the first thing that we're going to do is we're going to import a bunch of libraries. I'm going to quickly explain all of them. So the matplotlib one helps us plot graphs. The pandas one is kind of like Excel in code. It helps you deal with CSV files and Excel files. Train test split will help us split the data between train data and test data. I'll explain that later. And then the linear regression algorithm is the one that does the whole trying to figure out what is the best fitted line. And this is just some code for plotting the graph that I didn't want to write by hand. Okay, cool. So the first thing we have to do is we have to import a data set. We're going to do that right now. Salary data.csv. And I'm going to run these sequentially so I know they actually work. Okay, good. It does work. Then what we have to do is we have to kind of get data. But before we do that, let's look at the data set. Jupyter is kind of nice because it gives you this like spreadsheet-like look for CSV files. On this column is years of experience. That's our X1, if you remember. And salary is our H of theta, or Y. That's the thing we're trying to predict. So we really need to kind of separate this into two things. And one thing is going to be all those X's, X1, X2, X3. In our case, we're only going to have one thing, which is years of experience. And then on the other side, there has to be a thing we're trying to predict, which is salary. So the way I'm going to do that is I'm going to use this nifty iloc function from pandas. And I'm going to do this. I'll explain what I'm doing in a second. So basically, what I'm doing here is I'm saying, give me everything but the last column, and that's going to be X, and then give me the last column, which is going to be Y. We can think of Y as H of theta. I'm going to run these real quick, make sure they work. Yep, they're working. Cool. Now that we have this, we have to split the data between training data and test data. So in classic software development, what you have is this whole concept of testing your code. In machine learning, the way you test your model or your code is you kind of have you have your training data on which you train your model on, and then you have test data that the model hasn't seen yet, and that's how you test your model to make sure it's actually doing what it's supposed to do. So that's kind of the concept of testing and how you can relate to classical software engineering. So there's this handy function, train test split, that does that for us. So what I'm going to do is I'm going to split data into X train, X test. X train is going to be used for training, X test is going to be used for testing, and then Y train, Y test, same thing, only with Y variables. And then I can do train test split, X, Y, test size, it's going to be 0.2, and then random state, it's going to be 0. So I have to pass the thing that I'm going to try, the thing I'm going to split, and then I have to pass. You don't have to pass test size, but basically it's saying how much of this X and Y you want to go into a testing bucket, which it's common to do somewhere around 20% as far as how much data you have for testing. And then there's this random state algorithm, the random state parameter. There's some randomness in linear regression, and when I run this code multiple times, I want result to be the same. So that's why I put this here. All right, cool. Now to the fun part. We're actually going to instantiate our linear regression class, which is going to do the algorithm for us. I'm going to do this thing called fit. All right. What this fit does, if you remember from that from those slides, it basically finds the best fitting line. It finds that, it draws a bunch of lines and it picks one. So that's what this fit does. It's learning based on the parameters that it has. Let me run this real quick, just so make sure it's working. Cool. Now that it's found a line, we can actually predict based on the test data. Let's run that real quick. There we go. And now when we predict it, let's plot this so we can see what we did. And this is actually really exciting. I don't know if you can see, but what I did here is I predicted the values, and we can actually, let's not even look at a graph. Let's look at ypred, and let's look at y-test. So y-test are the actual values, ypred are the predicted values. And as you can see, it says 40,000 something, and we're 37, so it's not that great. But then here it says 122, and it's 122 here. Here it's kind of off. Here it's pretty good, and then 11.6, still okay, and then 10.07, 10.09. So it's mostly accurate, right? And to visualize what we did is, if you remember that, again, graph from slides, all these red data points, those are our real data points, our trained data points, and then this is the slope of the line that was kind of predicted based on that. And as you can see, it's kind of it's a pretty good fit. It's not perfect, and it should not be perfect. There's always going to be some problems, but it's predicting fairly well. That's kind of it for the coding example. And again, I'm sorry, I know I'm going super fast, but I'm trying to get everything done on time. So this is a very random, but I like to kind of throw in random facts about me. I love training dogs. I train working dogs for fun. So this is me training dogs, and that's kind of what I like to do in my free time. This is me on GitHub. This is me on Twitter. By the way, on my GitHub, there's a repo called ML for Beginners, and you'll find this code there. You'll also find another algorithm called KNN, which you can check out. It's a classification algorithm, and this is my website where I write a bunch about startups and machine and Python and Ruby and JavaScript, and I don't know if I have a machine learning blog post out yet, but I'm planning on doing one. 2 days ago I joined a company called ScriptDrop. If you want to check us out, we're hiring. It's scriptdrop.co. We're a Elixir shop. We have a bunch of stuff going on, that's about it. It's time for QA. If you guys have any questions, let me know.